Assalamualaikum warahmatullahi wabarakatuh and greetings to everyone. Welcome to our Mathematics 1 group project presentation titled Trigonometry in Action, Real World Measurement Around Campus. This project prepared by our group as part of the Bachelor of Vocational Education Building Construction Program. Okay, so this is our group members. To completing this group project, we work together as a team, content of 5 members. Each member was assigned specific roles and responsibilities according to their own skills and strengths to ensure the project worked perfectly. Okay, begins with an introduction of our group members followed by a clear table of content outlining the title and objective, field photos with field description and calculation summaries, as well as our discussion and teamwork reflections, and finally the conclusion of our overall findings.
For this part, I will explain the three main objectives of our project. Our first objective is to apply trigonometry concept and principle to real-world measurement. This means we use trigonometry to estimate height, distance, and angle around our campus. The second objective is to conduct real field measurement. We use basic tools like measurement tape, clinometer, and even shadow to collect accurate data during our fieldwork. Our third objective is to relate trigonometry formula to real-life situation. We apply this formula to actual structures such as building, tree, straight line, and staircase. This helps us to understand how trigonometry to use in everyday life. So overall, these three objectives show how trigonometry can be applied in both theory and real-world situations.
Field activity 1, height of a building. So these are the photos when we take the measurement for the height, distance, and angle of elevation during our field activity. So based on diagram 2, these are our sketches based on our field activity. From the field activity, we collect the data. The first data we collect is horizontal distance from observer to base t 3.0 meter, the angle of elevation theta 20 degree, the observer eye height above ground hopes 1.55 meter, and the estimate of the height of the building h 2.63 meter. So the formula we use to solve this problem is h equal to d tan theta plus observer height. Next is calculation summary. So we already collected the data. The data we had is observer eye height above ground hoped 1.55 meter, horizontal distance from observer to base t equal to 3.0 meter, the angle of elevation theta is 20 degree. So first, we must calculate the tangent of the angle. So we already had the value of theta, which is 20 degree. So we must calculate the tan 20 degree equal to 0.36 degree. Next, we must apply the formula. The formula we had is h equal to hoops plus t multiplied with tan theta. So the value for hoops is 1.55 meter plus 3.0 meter multiplied with 0.36 degree. We must calculate the multiply first. So the answer we get is 1.08 meter. Next, 1.55 meters plus 1.08 meter equal to 2.63 meter. In conclusion, the estimate of height the building using measured elevation angle and distance is 2.63 meter.
So this is our field photos for field activity 2, slope angle of staircase. We have the vertical height, rise, and horizontal distance, sine.
For this slide, I will present the field description for field activity 2, which is focused on determining the slope angle of a staircase. From our measurement, we recorded two key values. First, the vertical height or the rise, which is 6.5 inch, and this convert to meter. So so 0.16 meter. Second, the horizontal distance or the run, which is 4 feet for inch, and this convert to meter, so 1.32 meter. To calculate the slope angle, we use the formula tan theta equal rise dividend by run. This value from the foundation of our calculation and allow us to identify the exact angle of the staircase. Next, I will explain the calculation summary. Using the rise of 0.16 meter and the run of 1.32 meter, we apply the formula tan theta equal rise over run. This gives us a value of 0.12. To determine the angle, we take the inverse tangent of 0.12, which is result in 6.84 degree. This shows that the staircase has a slope angle of 6.84 degree, and importantly, this angle is below the maximum limit of 12 degree, meaning the staircase meets the accessibility and safety requirement.
For this field activity, our task is to determine the distance between two landmarks. This situation does not allow direct measurements, so we are required to use a mathematical approach. From the photograph, we can identify 3 key points. The first is the landmark on the left, which is the street light. The second is the landmark on the right, which is the signboard located near the parking area. In the center, we have the observer, who is the individual responsible for taking the measurement. The observer remains at a fixed position and measure the distance from the location to each of the 2 landmarks. These 2 measurements from 2 sides of a triangle. The remaining sides of the triangles, which is the value we are trying to determine, represent the actual distance between the 2 landmarks. Since it is not possible to measure this distance directly due to opticals, we apply a trigonometric method to calculate the unknown length accurately. In this part of the activity, we describe the field setup and the measurements collected during observation. The diagram shows the observer standing at a fixed point with 2 landmarks positioned on opposite sides. Landmark 1, which is the street light, is located at a distance of 9.41 meters from the observer. Landmark 2, which is the signboard near the parking area, is located at a distance of 5.57 meters from the observer. Based on the observer position, the angle formed between the 2 landmarks is 60 degrees. These 3 values, 2 distance and 1 included angle, form a triangle that allows us to calculate the unknown distance between 2 landmarks because we know both side length and the angle between them. The most suitable method to use is the law of cosines. The formula for this method is written as C square equals A square plus B square minus 2AB cosine C. This formula enables us to compute the third side of the triangles, which represent the actual distance between landmark 1 and landmark 2. In this section, we present the detailed calculation used to find the distance between the 2 landmarks. Using the law of cosines, we substitute the field measurements into the formula. We begin by squaring both known distance. The distance of 9.41 meters when squared gives 88.55. The distance of 5.57 meters when squared gives 31.02. Next, we calculate the product involving the consist of the included angle. We take 2 multiplied by 9.41 multiplied by 5.57 and then multiply by the constant of 60 degrees. Since the constant of 60 degrees is equal to 0.5, the entire expression simplifies to 52.41. We then apply the law of consonance by combining these values. We add 88.55 and 31.02 and then subtract 52.41. This result in 67.16. To obtain the final distance, we take the square root of 67.16. The square root gives a value of approximately 8.2 meters. Therefore, the calculated distance between the street light and the signboard is about 8.2 meters.
Okay, third, the field activities we choose is field activity 6. Height of street light using a shadow method. In this activity, we begin with the field photo showing the street light and its shadows. Okay, followed by the field description that explain all measure values. First, height of stick H1, the values is 0.69 meters. Second, length of stick shadows S2, the values is 0.35 meters. Third, height of street light H2 is the unknown height. Lastly, length of the street light shadows S2, the values is 4.28 meters. So the formula we use is H1 over S1 equal to H2 over S2. Okay, finally, the calculation summary where we determine the height of the street light using the shadow ratio method. To calculate the height, we took the height of the stick, which is 0.85 meters, and multiply by the street light shadows length, which is 4.25 meters, and then divided the result by the stick shadows length, which is 0.35 meters. After carrying out the multiplication and division, the final value obtained is approximately 8.43 meters, which is represent the height of the street light.
To begin this presentation, let's look at the methodology validation and project achievement section. The main objective of this segment was to confirm that the trigonometry concept will learn function effectively in a real-world measurement of structure in the field. We are pleased to report that the project successfully completed all tasks. The calculated result, especially for determining object height and slope, were found to be plausible. This formally validates the efficiency and effectiveness of applied formulas such as the Tagon and the Smiler-Trigon principle in a practical setting. Next, we move on to the analysis of critical issue and primary error that we encountered. Our analysis found that the primary source of error stemmed from instrumentation issue. This was mainly because basic two-way utilization, which significantly impacted the accuracy of the angel reading we obtained. A major challenge was maintaining reading stability and achieving correct horizontal alignment over the uneven terrain. This difficulty was a major source of observational error. Collectively, this finding indicate the necessity for stricter measurement protocol and a higher degree of precision in tool handling. Based on the problem faced, here are our recommendations for improving project project quality in the future. We recommend that future project utilize more precast tool, specifically digital kilorimeter, to option consistent and accurate engine reading, thereby reducing instrumental error. Additionally, comprehensive protocol training and the practice of cross-checking data in the field are critical steps to improve overall data collection efficiency and accuracy. In conclusion, this project successfully reinforced our understanding of trigonometry application and enhanced our physical skill in the framework.
For this reflection, I learned two important things. First, I learned about the importance of teamwork and clear communication. Good communication also makes sure we avoid to do mistakes and understand what each person needs to do. Second, I learned how trigonometry works in real-life situations. By measuring height, slope, and distance around the campus, I can see the formula are not just theory. They are used to solve real problems, like finding the angle of a staircase or estimate the height of a building. So overall, this activity helped me to improve my teamwork skill and understand the practical use of trigonometry in daily life.
For teamwork reflection, through this project, I learned how teamwork helps us complete tasks faster and more accurately by sharing rules and communicating well. I also saw how trigonometry is used in real life using shadow, angle, and measurement to find heights and distance. This project showed me that working together and applying math can solve real problems easily.
For this project, I had the opportunity to work closely with my team, and the experience strengthened our overall teamwork. Throughout the process, we learned how to communicate more clearly and ensure that every task was divided fairly among all members. This made it easier for us to complete each part of the assignment efficiently. During the field activity, we support one another, especially when taking measurements, analysis data, and confirming the accuracy of our calculations. This cooperation helped us avoid mistakes and ensure that our results were reliable. Overall, this project showed me how useful trigonometry is in real-life situations, particularly for determining height, angle, and distance more accurately. It also taught me that importance of teamwork, responsibility, and consistent communication in achieving a successful group outcome. Thank you.
Finally, I will share my personal reflection on this project. For me, this project was an invaluable experience as it strongly reinforced my understanding of trigonometry through direct field application. It enhanced my meticulousness in data recording and improved my problem-solving capabilities when confronting technical and instrument error. Overall, this experience is crucial for building my confidence in handling future practical mathematical assignments.
Okay, so this is my teamwork reflection. This project helped me understand that trigonometry becomes much easier to appreciate when it used in real situations rather than just on paper. By applying the formulas to real measurements, I saw how angles and distance put together to solve problems that would otherwise be difficult to measure directly. Working in a team also taught me how important it is to support each other, share ideas, and divide responsibilities so that every task is completed smoothly. We communicate closely, correct each other's mistakes, and combine our strength to get accurate results. Overall, this experience made learning more meaningful and showed me how teamwork and mathematics can complement each other in practical field work.
In In conclusion, the Trigonometry in Action real-world measurement around campus project has effectively helped us understand how trigonometric concepts are applied in real-life situations. By measuring height, slope angles, and distance around the campus, we were able to see how trigonometry is used by professionals such as engineers, architects, and surveyors. This project also strengthened our skill in observation, data collection, and accurate field measurement while improving our teamwork and communication throughout the process. That's all from us. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.
Okay, so that's all for our group presentation for this group project. And thank you everyone for listening and your cooperation.